So for this one, we're trying to conduct a hypothesis test, significance test for proportions. And I'm reading it, I'm seeing that we want to test the claim that the majority of voters support the candidate. So the null hypothesis is always, no, there's no difference. He doesn't have a majority or she doesn't have a majority. And then what we want to test is that it's greater than 50%, that they got the majority. Now, what we got to remember about all this is that the center of this HO says the center of this distribution is 0.5, and that says nope, the candidate doesn't have the majority. So we know the central limit theorem tells us that all these samples of size 400 will fall within a certain range of 0.5, and anything that falls in that range will just be due to chance variation. We want to show, in order to show that this voter has this candidate has a majority, we got to see if the test statistic will fall out here. So this distribution has a center of 0.5, and it has a standard deviation of 0.5 times 1 minus 0.5 over n. This is I'm using that p formula times 1 minus p. Now I don't want to use p hat here because we're talking, the p hat number, the 205 out of 400 isn't the center of this distribution. The 0.5 is. Okay, so that's why you always want to make sure. My process is I always set up HO and H1, make sure I've got that number there. These two numbers will always be the same number and not from the sample. They'll usually give us some other number, and here it was the majority. And then that's the number that you're going to use down in this formula to calculate the standard deviation. I guess I should have put not n, but I should have put 400 there. Okay, now we're going to multiply that. So 1 minus 0.5 is 0.5, and then 0.5 times 0.5 is 0.25. And then we're going to divide 0.25 by 400, and that's what I'm getting on my calculator, that the standard deviation is 0.025. So now I've got to find, I've got the HO and H1, I've got the standard deviation. Now I'm going to calculate the test statistic. So the first thing we need to do to figure out this test statistic is to figure out what the sample's proportion is. So 205 divided by 400 will be our sample proportion. By 400. So I got 0.5125, which is certainly larger than 0.5. But we got to see if it's due just a chance or is it actually much larger. So to get the z-score, we're going to take the sample proportion minus what we think the center of the distribution is, and we're going to divide it by this standard deviation we just calculated. So that's going to give me 0.0125 on top and 0.025 on the bottom. Divide those. So when I divide those, I get a z-score of 0.5. It's unfortunate it's 0.5 because with all these other 0.5s, but that's what we're getting for test statistics. So that's telling me on a standard normal curve, if the mean is 0, I've got this z-score of 0.5. I need to find this tail area because that's what my p-value is. That's going to be, so they don't want to use critical values, so we'll use the p-value. So I'm going to go look at a normal curve table. So looking at this normal curve table, I'm seeing when z equals 0.5, I'm getting a number of 0.6915. So what that is, that's this area to the left, the 0.6915. So to get that red area to the right, we have to do 1 minus that. This is one of those greater than flavors of HO if you watch that other video I made. So 1 minus 0.6 915, and I'm getting a p-value of 0.3085. So we've recorded my test statistic. I've got a p-value. Now I got to make a decision, and they're telling me to use a 5% level of significance, right? Well, this is a lot larger than 0.05, so I can't reject HO. That means the candidate does not have a majority. It's just the result was just due to variation, chance variation. Hope that helps.